Hi, Patterns. Okay. First of all, on if my interest is sincere and my interest in the truth, it is sincere. Right now, I don't see the problems that your system addresses, which the current models don't address. You could be creating another system that could explain things, but until there's a difference between one system and the other, then really the only reason to use one system or the other is if one is more mature, and has more calculations worked out for it. And so QM and relativity are hard to beat in terms of that. But I am interested in the truth. I have no problem changing my views on things. I mean, I always sort of thought the universe should collapse. I kind of still feel that way, but I go with the evidence of what seems more likely to be the truth now, which it looks like the universe is going to keep expanding, expanding. I don't know. I'm just going with whatever seems to be the case, and and that's what that's what I would do. On the other hand, I don't have a lot of hope um, about your particular system or not. I'm just investigating it. So I don't have a lot of hope that, okay, I'm going to get a bigger scientific truth. I don't know. I'm trying not to be biased about that. But what I do hope is with systems like this, sometimes, even if they're good systems, it could take hundreds of years, right, to exhaust them and develop them really well. And obviously, I'm not here to wait 100 years to get something from this conversation. But before they're entirely exhausted, I can look at these ideas for philosophical ideas, for metaphors, just as I would from a model that was well proven. So I am interested, and I have a genuine expectation of benefiting from our conversation. But you can't take that as an assumption that I think you're going to convince me that we need a whole new physics in line with your theory of astrometry. Um, but I am genuinely interested, and I'm not being disingenuous. Now, on Zeno's paradox, it's interesting that you would do that. Zeno's paradox is proved two different ways, really. It's solved, I should say. Uh, First of all, the idea that you have to move to the halfway point, you have to move to the halfway point that remains, and so on, it involves points on a line, and you never, the idea that there's infinite movements ignores the fact that movements start to take an infinitesimal amount of time, trending towards zero. I'll deal with the quantum mechanics idea in just a moment, the fact that you can't actually have it, that there are minimal intervals of time in which things can happen due to quantum mechanics or according to quantum mechanical theory. Um, so just assuming you could divide the space infinitely, as Zeno did, he just approached it wrong, because as the halves of the road get smaller and smaller, the time also gets smaller and smaller, and both of these things approach a limit of zero remaining distance. And if you do infinite sums, well, you can add a bunch of things up, and it makes perfect sense too, because I mean, the reasoning that shows why you can cross the road in a finite amount of time, even though you're passing an infinite number of points, is that there isn't really points, right? We use calculus now, and there's little intervals, infinitesimals. But instead of pretending that there's an infinite number of points to traverse, um, you have to realize that what you're doing is, infinity is like a mathematical concept. You're just saying, and we do this forever. So we split this in half forever. Well, if you split a distance in half and traverse it, um, you've traversed the distance one. Each of the halves was size a half. If you do it again, so it's 4 quarters, and you add them back up, you'll get one. If you do it again, and so there's 8 pieces, and you add them up, you'll get one. And that's always true, no matter how many times you make that step, so including infinite number of times. So if you really could cut it into an infinite number of little pieces, when you add them up, of course, they're still going to add to 1, because through induction we can prove that. We know um, that it's true for a particular case and it's true for the next case. And if you run through all the next cases, then you've addressed the infinite issue. Now, you mentioned that weight. Um, in quantum theory, every distance takes a finite amount of time. But in quantum theory, there can't be an infinite number of distances, right? At some point, you get down to this quantum minimal distance, and you can't split that in half. So in that case, of course, those finite, uh, tiny distances, quantum scale distances, can be traversed in a finite amount of time, and they can be summed up. And if you do that math, you'll find out, of course, you can cross the road. Scientifically, what I wonder is what open problems that are unexplained now. I mean, it's not enough for me just to say, hey, you know, we need to think of it in this different way. We need to know what is the problem with the current system that the new system solves. We want something that the current system has trouble predicting or can't predict, that your new system can predict and has no trouble with. And I think you have such things in mind, but I don't know what they are. And this goes to the whole issue of divulging your theories and results. You don't have to divulge those, but if you want to have a scientific system, then you should maximize how much you divulge. You should divulge the weaknesses in your system that you recognize as weaknesses. You should divulge all of this so it's perfectly open to inspection. Now, you don't have to do that. But I think philosophically you should, and scientifically you certainly should. But on a personal level, you can make those decisions. I can understand. There's a lot of ideas I have. I'm still working on. I don't feel like presenting for various reasons. So I'm not telling you what to do, but I'm just saying that in terms of presenting this as a scientific uh, argument, for example, to someone like me, then you should probably divulge as much of it as you can, and that'd help me understand what I'm trying to understand about it. But thanks for the response, and I hope this all made sense to you. And I'll talk to you later. Oh, you did bring up the issue of what all the theories are based on, and I have some different disagreements with you. I mean, theories of black holes are not based on Newtonian mechanics. Newtonian mechanics doesn't explain that at all. They're based on the theory of relativity. But so it's pretty modern science in which, yeah, light falls in a gravitational well, and et cetera, et cetera. So, okay, anyway, more later.